Rapid Spanning Tree Protocol, or RSTP. This Layer 2 loop prevention protocol not only addresses the limitations of traditional spanning tree protocol, but it also converges a switched network in a rapid amount of time. But how do you configure RSTP, and what commands do you use to validate that configuration on Juniper switches? These questions plus more we'll be going through in this video. Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, what I'm going to be going through very quickly, because it's not very complicated to do, to be honest, is how to configure RSTP, or Rapid Spanning Tree Protocol, on Juniper switches. And as I just said, it is not complicated to do. And this is assuming that you know the theory around RSTP, why it came around, why it was created, and that was really to address all the limitations of STP, or Spanning Tree Protocol. So what I'm trying to say here is, if you don't know what Spanning Tree Protocol is, if you don't know what a root bridge is, if you don't know what a root port is and a designated port, and why STP was created in the first place, i.e. to block a layer 2 loop at the switching layer, then please check out this link. It's a video that I've done that describes all the theory, both from a basic to advanced level, on STP and all those elements I just discussed. But in summary and quickly, RSTP was created to address those limitations of STP, i.e. it converges successfully, but it does so very, very slowly. And guess what? Rapid Spanning Tree Protocol reconverges a network when there's a change in topology a lot more quickly. And it also brings in these new aspects to RSTP that you don't have with STP, such as the sync mechanism, which is when that switch or switches are sending out a proposal BPDU, or Bridge Protocol Data Unit, and another switch is sending out an acknowledgement or an agreement Bridge Protocol Data Unit, or BPDU. And again, if you don't know what RSTP is and the difference between RSTP and STP, just check out this link. And I'm saying this because before I show you the configuration, how simple it is, I just want to ensure that you know the theory around STP and RSTP before we go into the configuration, and in a later video start playing around with MSTP, or Multiple Spanning Tree Protocol. But enough of me talking, let's just go straight into the lab and let's just show you how quick and easy it is to configure RSTP on Juniper switches. And here's the lab that I'm going to be using to configure RSTP, Rapid Spanning Tree Protocol. As you can see, there's 4 switches. We've got switch 1, we've got switch 2, we've got switch 3, and we've got switch 4. And there's obviously connectivity between the different switches, because what we want to do is we want to simulate that of a loop. So obviously RSTP blocks that loop by making one of those interfaces discarding. Now, all the configuration I'm going to be doing is really going to be from switch 1's perspective, and I'm only going to show it once because honestly it is so straightforward, so simple, that if I show it on switch 2, switch 3 and switch 4 as well, it's going to be overkill, quite frankly, and you're going to get bored and you're just not going to watch this video anymore. So I'm keeping it short, keeping it simple. But let's go back to the lab. What you can also see in the lab is there are these hubs. So we got this hub here and this hub here. And that's important because in the STP world, it didn't really have this concept of a shared interface. So if we look at the interfaces here, here, and here, and up here for those different switches, they are configured to have a shared medium with or through a hub. And I do appreciate a hub in today's networks is very, very rare, to say it politely. But the RSTP allows for that configuration. But STP didn't have this concept of, well, having a shared medium with this hub in the middle. And also, looking at the lab, what you can see is that all these switches, of course, have different bridge identifiers, and that bridge identifier is made up of a priority value and of that system's MAC address. not of the MAC address of the interface, but that of the hardware, of the chassis itself. And if you know the theory, let's ask yourself rhetorically, which switch will be the root bridge? Will it be switch 1? So will it be switch 1 here, or will it be switch 2, switch 3, or switch 4? Well, if you know the theory, I hope that you've quickly identified it will be switch 4, because it has this priority of 0. In the STP and RSTP world, lower the value, the more preferred that actual switch will be, in this case 4 becoming the root bridge. So switch 4 is going to be the root bridge, and all the other switches, switch 1, switch 2 and switch 3, they're going to decide on which port is going to be a root port and which ports are going to be designated ports, etc., based on the best cost or the lowest cost to get back to the root bridge. But we can also see, just looking at it, that the switch 2, the priority is 4K or 4096. Interestingly, in Junos, you don't have to say and define 4096 on the interface. You could just define the priority as 4K, 8K or 12K. I think that's very helpful, to be honest. And you can see it on switch 2 it's 8K, and also on switch 3 it's 4K. But by far switch 4 has the best priority, the lowest priority, and thus it is the root bridge. But as I said, all the configuration I'm going to be doing is on switch 1. An important point to note as well is the different types of links. And I've already said that these links here, they're shared, aren't they? So because we've got this hub right in the middle. So I'm going to show you on Junos how to configure interfaces to be a shared medium in the RSTP speaking world. But we can also see the interface between switch 1 and switch 2. It's what's referred to as P2P, or point to point. That's another type of interface that you get in the RSTP world that you don't really get in the STP world. But also note here, and I'm saying this now, I don't want it to catch you out, we are going to configure this interface here, the GIGI00 interface, as a fast Ethernet port. That is going to dictate to switch 2 which way is it going to go to get back to the root bridge, i.e. is it going to go via switch 3 to get to the root bridge, or is it going to go via switch 1 to get to the root port, to get to the root bridge? And again, that is based on lowest cost. But remember the theory, in the RSTP world there is this concept of long cost, i.e. you've got 32 bits dedicated to defining what that cost value is in the RSTP world. In the STP world, it was only 16 bits, and that was what was referred to as a short cost. So you're going to see a lot bigger numbers because of this long cost. Of course, you can define those values. But enough of me talking, just wanted to give you a quick high level view and understanding of the lab. But now let's go on to switch 1 and do that configuration. And here we go, I've logged into the command line interface via secure CRT onto switch 1. So let's just go into the command line interface into configure mode, and we're on the configuration terminal, the part to configure switch 1, of course. Now don't forget, we want the interface GIGI000 to be fast Ethernet. So that's the first thing I'm going to do. All the other switches, by the way, are pre-configured. They're configured already. I'm only going to show it once to keep this video as quick and to the point as possible. But first, let's configure that interface to be fast Ethernet, i.e. 100 megabits. So if I should just do set, not groups, but set interface GIGI000 speed, hit question mark, and you can see right here 100 megabits per second. And there we go, I've just configured the interface to be 100 megs, but of course it's not configured yet. Now let's go into edit protocols RSTP. Let's do a quick show, and you can see there's absolutely nothing configured there. First thing we're going to do is define what interfaces do we want to participate in RSTP. So if I do set interface, and let's do GIGI000, and I'm just going to enter these quickly, and GIGI001, and GIGI002, and if I just do a quick show, you can now see we've added a little bit of context to the RSTP protocol. But again, note the GIGI000 interface is point to point. The GIGI001 and GIGI002 is a shared medium. So we need to define those interfaces respectively to have that interface type. So let's do set interface GIGI000, and if I hit question mark, you can now see all these different attributes you can enter in for the interface configuration for RSTP. So you could say this is, just for example, not a root port. So what this means is that if you've got multiple interfaces, uplink, downlink, doesn't matter, you are saying that I don't want this GIGI000 interface to ever be a root port to get back to that root bridge, to get back to switch 4. You can also define the priority of the interface, and that's important when it comes to the election of which is going to be a root port and a designated port and a discarding, or maybe an alternate or backup port. You can disable this as well, so we could disable spanning tree on the interface itself. We can also define it to be an edge port. That's important because if you have a user connected directly into switch 1, you don't want the user flooding in BPDUs, RSTP bridge protocol data units into the network. So you could define this to be an edge port and then disable the BPDU block on edge, i.e. if I receive any BPDUs on an edge interface, just block it immediately. But what we need to do is actually define the mode. So if I enter in mode here and hit another question mark just to walk you through it, we could define it to be point-to-point or shared. GIGI00 is point-to-point, so I'm just going to enter that in now. Let's do a quick show. You can now see the interface GIGI000 to switch to is point-to-point. And actually, if I hit the same command again, so let me just hit up and let's just do the cost. This comes back to that long cost value. Note the cost here, it can go up to, I'm not even sure what number that is. It's what, 2 billion, whatever that is. Yeah, 20 million. It's a huge number to say the least, but that's because of that long cost value, those 32 bits that I was just mentioning. If this was SDP, where it's short cost, by default, it's going to be a lot smaller because of the 16 bits. I just wanted to show that very quickly. It's quite interesting. But what we need to do is do the same for the GIGI001, but I need to define the mode to be shared, because between switch 1 and switch 4 for the GIGI001 and GIGI002 interface, it is a shared medium. So I'll just hit up, do the same here, and just do show now, and you can see it's getting a little bit more accurate, isn't it? So we've got our interface, we've got our mode, point-to-point, and we've got our shared for GIGI001 and 002. But what's missing? It's on the EVE-NG, on the lab in the background. We need to define the priority of this bridge, and that's important when it comes to the root bridge election, because regardless whether it be SDP or RSTP, when a switch initially boots up and is part of a SDP or RSTP mechanism, part of a network that's running those protocols, each switch initially thinks that it is the root bridge, and it will send out those BPDUs saying, hey, I'm the root bridge, until it receives a superior BPDU and then says, okay, you're the root bridge, switch upstream, I'm inferior, you've got a better priority to me, or for retired, you've got a better, i.e. lower MAC address to me. So if I do set, how do you define the priority of that switch? Guess what? It is right here, the bridge priority. So here we define the bridge priority. So if I just do bridge priority, tap it out, and note here you can do it in increments of 4096, but we don't have to define 4096 and 8192 and 12 I don't know the math off the top of my head, but we could just do 4K, 8K, 12K, 16K, etc. So now if I just do 4K and do show, we can now see the bridge priority of switch 1 for this RSTP network. And don't forget, RSTP and STP has no concept of VLANs. This is just for this layer 2 network. This switch has this bridge priority of 4096, or 4K to keep it short and simple. Now coming back to that BPDU block on edge, just to show you, if I hit question mark, here we've got the BPDU block on edge. So if I actually done set interface GIGI0004, and I know it doesn't exist, but that's perfectly fine. And if I do mode edge, or it's actually just edge, Let's just do a quick show so we can see we've entered in Gigi004. Again, I know it's not there in the lab, but this is an edge port connecting to a server or an access point, whatever it is. This is an edge port. I can then do set BPDU block on edge. And if I do a quick show, what this basically means is that for all edge interfaces, which are configured to connect to edge devices, i.e. non-network terminals, no switches. If I receive a bridge protocol data unit on this edge port, I am going to, guess what, block it. That's pretty cool, that's very easy, and that's just a little bit of security to protecting your switching network. But of course I don't have a Gigi004 port, so I'm just going to delete that, and I'm also going to delete BPDU block on edge. And just do a quick show. And really, in terms of the setup, that's it. That's my interface Gigi00, point to point. My Gigi001 shared. It's the same for Gigi002, both going to switch 4. And I've defined my bridge priority. And I also showed you a little bit more in terms of how to configure the cost of the interface. But what else is there? Just to show you a little bit more. But of course, you can define the forward delay timer. So that's the delay time to go from discarding, maybe through the learning state if it's communicating to an STP enabled switch, and then into forwarding, i.e. 15 seconds by default. But the glorious thing with RSTP is it could go straight from discarding into forwarding. Hello time is the hello time of just those hello BPDUs being sent out, by default 2 seconds. The max age timer is basically the trustworthiness of that last BPDU. How trustworthy is that? System ID, honestly I don't know what this is. It's a system ID to an IP mapping. I will definitely look into that. You could do trace options. That's the Cisco's equivalent of a debug, so you could do trace options to look for particular BPDUs and flags and just do some troubleshooting. We can also force the version to be SDP. RSTP is enabled by default. And here's the extended system identifier. This is important if you have VRFs or routing instances. So in Junos you can have X amount of routing instances, and even though routing refers to layer 3 and RSTP is layer 2, you can have a different RSTP instance in the different routing instances. So you might just want to have a different system identifier for each one of those routing instances where you're running RSTP. But honestly, that's the configuration, very straightforward. So what I'm going to do now is do a commit and quit. And what we're going to do is we're then going to go through switch 1, switch 2 and switch 3 and see what are their interfaces. So we're going to validate from all these switches that RSTP, the network is obviously up and converged, and what interfaces are in which state and in which mode. Okay, so let's validate that RSTP is running. Let's validate that switch 1 is seeing switch 4 as the root bridge, and let's also validate the different interface types and modes for all of these switches, switch 1, switch 2, switch 3 and switch 4, just so we could see the overall topology of the network from an RSTP perspective. So what are some good show commands that you can do on Junos on the switches to validate RSTP? Well, if I do show spanning tree, you don't have to define spanning tree or show rapid spanning tree or show multiple spanning tree for MSTP. Just keep it simple, and it is simple, show spanning tree, and then if you hit question mark, you can then define, well, I want to look at MSTP, or if it's STP or RSTP, really it's the same. You can look at the bridge, you can look at the interfaces and particular statistics. So first let's look at the bridge. So, and if I hit question mark, what I'm going to do is I'm just going to do detail. Note you can look at a bridge for particular routing instances. As I was saying, you can have multiple RSTP or STP protocols instances running in different routing instances. We don't have that here, it's just the one, it's the default routing instances. But if I just hit enter on that, note here we are seeing the switch 1's root bridge details and the actual root bridge. Or let me say that again, what we are seeing here is the switch 1 bridge details and the root bridge details. So the local parameters is that of switch 1 because it's local to the switch. We are logged in on switch 1. We're seeing the switch 1 show commands, and you can actually see here 4096 2C and right at the end is the MAC address ending in 27:D0. That is the MAC address of switch 1. So this is local. And what it's seeing up top is, yep, it's running RSTP. It's in the global routing instance, as I just said. But here we can actually see the root ID of that root bridge. So here's the priority. I just checked, and switch 4 is absolutely configured to have a priority of 0. And if I just go over to switch 4, you can actually see here's the bridge priority here of 0. So why it's showing 4 here, honestly, I don't know. It's a free Junos image, so maybe there's a bit of a bug here. But this is absolutely switch 4 because here is the MAC address ending in 20:D0. That is the MAC address, the chassis MAC address of switch 4. But what we can also see is from switch 1's perspective is what is the root port to get back to the root bridge, switch 4. So the root bridge, the root port to get back to the root bridge is out of the GIGI 001 interface. The hello timer, the max age timer, all these timers here. When was their last topology change? And that happened all these seconds ago, whatever that is in minutes. But here we've just confirmed, basically, regardless of this little bug here, as I suspect it is, that the local bridge is basically switch 1, and switch 1 has agreed that switch 4 is that root bridge. But how can we see the other interfaces as part of this RSTP process? Well, if I just hit up and do show spanning tree interface brief, this is a very quick, easy command for you to use. We can now see all of those RSTP speaking interfaces and their port priority and the ID, not in terms of interface ID, i.e. GIGI 001 and GIGI 02, etc., because you can see that doesn't make sense. But what are those, yes, port IDs and port priorities, but right at the end, what state and what row are they actually in? So we can see for the GIGI 00 interface that this is forwarding. So we're forwarding traffic. This is a designated port to get to switch 2. We can see, as we've already saw, as we saw in the last command, the GIGI 001 interface is our forwarding state, and it is our root port. It is our row of root ports to get back to the root bridge. And we can see as well the GIGI 002 interface is blocking. Blocking is actually an STP terminology. In RSTP, this should say discarding, but same thing, minus slight differences there. But this is free software, so you can't complain too much. And this is alternate. Alternate means in the RSTP world that if the root port fails, i.e. it goes down for whatever reason, the alternate is there to take over, and then if GIGI 001 fails, the GIGI 002 will suddenly become that root port. And what I've done is I've just put into the background, as you can see, the GIGI 00 and GIGI 001 and GIGI 002 to have those respective rows and states. So we can see for GIGI 000, it's forwarding, it's a designated port. For GIGI 001, it is forwarding, it's a root port, and for the GIGI 002, it is an alternate port and is currently discarding. I've not put blocking because that's an STP terminology. But what about switch 2? Well, logging on to switch 2, if I go into the command line interface and let's just do show spanning tree interface brief, let's get those statistics, and now we can see our two interfaces. So the GIGI 000, which points back to switch 1, is our forwarding and root port, and the GIGI 002 interface is our forwarding designated port. So let's enter those in now. And there we go, those are switch 2's rows and their states of those interfaces. Let's do the same for switch 3, just so we're building the picture. So let's go into switch 3 and let's do that same command, show spanning tree. Oh, let's first go into the command line interface. That's always a good idea. Let's do show spanning tree interface brief. And now we can see which ones are discarding or blocking. It's a backup port, backup being the designated port on a shared medium fails, the backup port will become designated, and we can see which ones are root ports. So let's enter those in. And there we go, I've just quickly entered in those forwarding, route and designated ports. And note the Gigi 003 is discarding. It's a backup port for if that designated port, the Gigi 000 interface goes down. But let's finish off looking at that route bridge, those interfaces on switch 4. So here I am on switch 4. Let's just do a run show spanning tree interface brief. And what you can see as expected is that most of the ports, minus the one that has a shared medium, they're all forwarding, designated, minus the Gigi 003 interface, which is part of a shared medium, is blocking. And there we go. That's all the state and rows of those switches interfaces to get back to that route bridge, which is switch 4. So let's take it one by one. So if we look at it from switch 1's perspective, its route port is to get back to the route bridge is the Gigi 001 interface. So it's saying, yeah, my best route to get to the route bridge is down here. And what about from switch 2's perspective? Well, its route port to get back to that route bridge, switch 4, is via this interface here. And how about switch 3's perspective? Its route port is out of the Gigi 001 port. So the best cost for that to get back to the route bridge isn't actually this way. Nope, it's actually to go via switch 2 and all the way around. But what other commands can you do to actually validate RSTP? Well, let me just go to the top here and quit out of here and just do show spanning tree statistics and just hit question mark. So what you could do is you could see the statistics on the interface. Are there any messages in the actual queue related to RSTP for particular routing instances as well? That's not applicable here. And for the bridge, let's have a look at the interface. Let's have a look at the interface Gigi 000. Or actually, I'll just hit enter there and it's going to give me all of the statistics. So I can see the amount of BPDUs that were sent, that were received, when the next transmission of the BPDU actually is in terms of seconds. Topology change, that's what TC stands for, that have been transmitted and received. And any proposal and agreement that have been transmitted and received. And the same for the Gigi 001 and the Gigi 002 interface. So you can see there's been a lot of BPDUs that have actually been received on this interface. But let's do that same command and let's look at the bridge. So what we can see just under here is that it's in just the default STP context. Number of route bridge changes, there's been 1. Number of port changes, there's been 1 as well for that particular bridge, and it happened on this particular date and time. So it's just general statistics really, and RSTP is very straightforward in setting up and, as you could see, configuring. But just to summarize, really all the show commands you need to do, if you do show spanning tree, hit question mark, it's either going to be in the bridge or via the interface, or if you want to go into more detail, a little bit more detail or different detail, you can look at the statistics as well. MSTP is definitely for a future video. So that's it, everybody. That's the end of this video. That is the end of this part into how to configure and validate RSTP, or Rapid Spanning Tree Protocol, on Juniper devices, on Junos, on EX and QFX switches. And hopefully you've taken away that it is quick, it is easy to do so. You just go into configure command, configure mode, into protocols, define the interfaces that you want to participate in RSTP, maybe define their cost, maybe change some timers, but recommended best practice is to leave them to default anyway, and to define the bridge priority. And then we went into those different show commands, such as show spanning tree bridge detail, to see what is your local bridge parameters, who is that route bridge, when was the last topology change, what is your route port to get back to that route bridge itself. And then other show commands such as the show spanning tree interface brief, to see for all of those other interfaces that are participating in RSTP, what are their roles? What are their modes? Are they discarding? Are they forwarding? Are they designated? Are they route? Are they backup? Are they alternate? And again, RSTP brings a lot more options to the world of switching than its predecessor STP. So I hope you found that useful. Hope you found that informative. If you like this video, if you like my content, please give me a thumbs up. It's the best way to support my channel. Any questions or comments, let me know down in the comments box. I love hearing from you guys. Other than that, Thanks for watching and goodbye.